pass it. He flew in from where?
Connecticut.
Connecticut,
Well,
just to
just to be here tonight with
and
you.
tell us this very cool story. So how about a round of applause for John?
I haven't done anything yet. Don't overpromise. Thank you. It's great. It's really. I'm glad to be here. I'm glad to be here because it's about 17 degrees back in Connecticut. So if you have anything for me to do tomorrow, let me know. And the next day, I'll stay all weekend. I don't care about the rain. There's no ice and there's no snow. So my name's John Strasner. I'm Vice President of Workplace Strategy and Industry Relations for Human Scale. I've been with Human Scale for about 22 years and have seen the company grow from a little tiny company to a global manufacturer today, and we're pretty proud of our progress. I wish I was a shareholder, but I'm not. But we've come a long way with our sustainability, and I like to start, so what I'm going to tell you guys about, I'm going to tell you a little story about how Human Scale kind of found our North Star in this conversation, and a company that always wanted to do the right thing, but I'm going to tell you a story about how hard it can be to do the right thing, right? So I start out with this quote. I don't know if anybody here knows who Albert Schweitzer was, amazing author. So what kills me here about this quote is he passed away in 1969, okay? And he was writing about how we're destroying the planet through pesticides and insecticides and other toxic chemicals. I'm no mathematician, but let's just call that 70 some odd years ago. And we're still talking about it, which is crazy. So I want to tell you, I want to talk today about material transparency. And disclaimer, I am a fearmonger and a conspiracy theorist, unmitigatedly, unabridgedly so. And so I want to talk a little bit about toxic chemicals, toxic materials, right? You may have all heard this before, but we spend about 90% of our time inside, which is depressing. Think about that. You work 8 hours a day, you go home, you get a few hours to cook dinner and yell at the kids, and then you're in bed, you sleep another 8 hours. So that's 8 hours of working, 8 hours of sleeping, 3 hours of maybe hanging out watching American Idol. That's, what are we up to, 19 hours, right? That's 5 hours. Let's think about the commute back and forth, take another 3 hours out. God, you're lucky if you get 2 hours of daylight, right? Another way of looking at this is we spend 95% of our time surrounded by manufactured product. Manufactured product that we have no idea what's in it, okay? So Human Scale is a manufacturer. We've got a factory in Piscataway, New Jersey. We've got one in Fresno, California. We've got a couple others across the globe in different spots. We can make product and put anything we want in it, right? Anything we want in it, and we don't have to tell anybody. We don't have to get permission. We don't have to get approval or authorization, right? And if you're curious, for example, what's in those Cinto chairs that you've been sitting in for the last several hours, do you know what I can tell you? It's proprietary. It's proprietary. End of discussion, right? Think about that. So we spend 5 days a week, 8, 9, 10 hours a day inside of a building where we know the air in that building contains at least, you may know better than I, but 40% more carbon monoxide than the air outside, right? The toxicity levels inside these buildings are 2 to 5 times higher than what they are inside. And we wonder why, when we get our brightest minds together, we capture them in a conference room and we shut the doors, and at 3 o'clock in the afternoon we're popping Jelly Bellies and drinking cappuccino trying to stay awake. It's not because we're exhausted. It's not because we're bored. It's because we're breathing some pretty bad air, okay? But we're really, really used to this, and we're accustomed to it, right? And we don't give it much thought, okay? Conspiracy theory coming up in 3, 2, 1. Think about this for a minute. Anybody here have an allergy midlife that maybe you weren't born with? Maybe at 40 years, all of a sudden, you couldn't eat shellfish? Do you think it's because 40 years into your life, your body was like, nah, shellfish, we're not going to do shellfish anymore? Or do you think it might be because you had a bioaccumulation of toxic chemicals in your system, and they finally reached past your body burden, and you're having a reaction? I'm just saying. I'm not a doctor either, but I'm just saying, right? So, we don't give this stuff as much thought as we need to. And the reality is that there's no regulation here, okay? You can ask the EPA, and they will tell you that they are not in the business of regulating this. I'm going to tell you guys a little story. Want to hear a little story? I wish I could move around. I don't typically stand at a lectern. I'm free. I broke out. So, in 1976, the federal government, working with chemical lobbyists, wrote a law called the Toxic Substance Control Act of 1976. Pretty creative, right? They told the EPA, they said, hey, today we are making about 64,000 synthetic chemicals. Don't worry about it. Cows out of the barn. We can't go back in time and fix that because all those chemicals are going into product. Okay? Like people are buying those chemicals. And if we outlaw those chemicals, then the chemical companies have to stop making them and stop making money on it, and people are going to lose their jobs. And then you go back to those companies that buy those chemicals, and I those companies, they can't use those chemicals anymore, then those companies have to find safe chemicals to use. What a hassle. Let it go. Worry about the new stuff, but here's the way you got to do it. We are not going, anybody here ever hear the term the precautionary principle? Okay, we're not going to adhere to the precautionary principle which says better safe than sorry. So EPA, the burden of proof is on you. Okay, so that what that means is if you discover that a chemical out there is toxic and harmful to human health, it's up to you to do the research and compile the data and then pursue the chemical company in a court of law and convince them to stop making it, right? So I don't know about you guys, but this is what I envision with this story. EPA somehow finds the funding to do research and figure out that a chemical is in fact toxic. And then they turn it over to like a 19-year-old college intern who's just working there for the summer, right? Probably not even getting paid. And they go to the courthouse, and the chemical company, BASF, shows up with 27 attorneys. Because by God, they are not going to stop making that chemical, right? That's how it works. So think about the FDA. That's the way it's supposed to work, right? So what do you have to do if you want to make a pharmaceutical in this country? You got to get FDA approval. That could take 3 or 4 years, right? Because the burden of proof is on the pharmaceutical manufacturer to prove to the FDA that what they want to manufacture and distribute is safe. Aside from the list of all those side effects like sudden death, coronary disease, liver failure, aside from all that they put in the pharmaceutical commercials. So here's what happened. Since 1976, we've introduced another 20,000 synthetic chemicals. Guess how many the EPA has inventoried? For a free human scale metal straw. I love your enthusiasm. 200, 1%, right? So of the 20,000, they've inventoried 200. And they've banned or regulated 5. That's because the burden of proof is on the EPA, right? So this is what happens when you have that kind of a situation. It takes a very long time for anything to happen, right? This is government bureaucracy at its best. And I hate to be pessimistic, but it's not going to get any better. So it took the EPA 21 years to regulate lead paint. It took them 19 years to regulate asbestos. So you guys see how this doesn't work very well? So as a manufacturer, it works out really well for us because here's another little quiz for you. What do you think is cheaper, the toxic chemical or the safe alternative? Right. The toxic chemical is pretty damn cheap, I'll tell you. They're cheap, they're easy to come by, and they're totally legal. And so green chemistry is just not properly incentivized to find better alternatives. And we don't even know the synergistic qualities of these chemicals, right? So not only is the EPA not inventorying these chemicals, which means understanding what's in them, the chemical companies don't even have to tell the medical community how to find trace elements of the chemical if you have exposure. They're not even required by law to do that, right? So it's kind of crazy. So not only are we not inventorying those, but we don't know what happens when we combine chemicals, right? We don't know what happens when we combine chemicals. And in fact, we pre-pollute before we're even born. They did a study in 2005, which I think is appalling that you never hear of, okay? 2 research laboratories working with the American Red Cross tested umbilical cord blood of newborn babies in U.S. hospitals, and they found 287 synthetic chemicals, everything from pesticides, insecticides, to PFCs, from fast food wrappers and clothing and textiles, in the umbilical cord blood, which is absolutely insane, right? And there's even a scientific term for this today, right? Called body burden. That's how terrible. So not only do we not freak out if you get exposed to a toxic chemical, right? You would think that we would, but we don't, because the medical community goes, oh, don't worry about it, because as long as we don't exceed your body burden, you're going to be okay. Nobody's upset that we're exposing ourselves to toxicity. As long as we don't exceed the body burden, we're okay. Who decides what the body burden is? What if I want my body burden to be like 0, right? I go to the doctor once a year, I get my physical, I get my blood test, and when I get my blood tests back, you know what it tells me? What my cholesterol level is, what my blood sugar is. Do you think I ever get any kind of a toxicity report? Never, right? So if you are allergic to something, and you go to the doctor to figure out what you're allergic to, has anybody done this? They prick you with all the things, pet dander and pollen and peanuts and shellfish. But do they ever prick you for PVC, PFCs, formaldehyde, all the things that you're exposed to on a daily basis? Never. So the medical community is completely fear-mongering in 3, 2, 1. I think we're on the verge of a medical crisis. I think this is a healthcare crisis. We're really, really close to that. I'm genuinely concerned. If you're wondering how you get exposed to something that's a toxin, here's what experts tell you. Experts tell you that we eat our buildings, right? Think about that for a minute. All of these toxic synthetics are mixed together and put into materials. They're bonded unnaturally. And the minute you put it in a space, what happens? It starts to leach and it starts to off-gas. Anybody here work on a LEED project? What do you have to do with a LEED project? You have to flush the building? Why do you have to flush the building? Because the stuff that we're putting in the building is so toxic, it's off-gassing, and if anybody goes into that building before it all off-gasses, they're going to get sick. So we open the doors and the windows and reverse all the air ventilation, and we just flush it all outside, because out of sight, out of mind, right? Green Guard certification too, right? Think about Green Guard. Green Guard basically says it's okay because it's off-gassing at an acceptable level. Whose acceptable level? Who decides that? If it's off-gassing because it has toxins in it. That's why it's off-gassing. They hung a vinyl shower curtain. You think about vinyl, right? We use PVC all the time, everywhere, do we not? It's everywhere. Banding around tables, all the cables, right? It's the most toxic plastic on the planet. When it burns and when it melts, it gives off dioxin. That's the worst toxin known to mankind, right? Firemen in this country have the highest rate of cancer because when they respond to a fire, that smoke is so toxic, right? They hung a vinyl shower curtain for 28 days, measured 108 different VOCs. that off gas from something like a vinyl shower curtain. Anybody here open up something that's new and you can smell it? Right? I always get excited. I'm like, that's new plastic. I love the smell of new plastic. I make my kids smell it. I'm like, that's new. Smell it. That's new. That's good stuff right there. Right? Or a car. You ever get in your car and you look at the windshield and it's kind of smoky, hazy? And so you grab like a dirty Kleenex off the floor of the car and you got kind of rub a little circle and you're like, damn it, that's on the inside. And once you start, you got to finish it. So then you're like doing your whole windshield with this dirty Kleenex. Do you know what causes that film? That's PVC off-gassing. It creates a film on the inside of your windshield because there's so much PVC in your car. But remember, it's totally legal. It's totally legal. So if you look at something like a halogenated flame retardant, these are some exposure routes, right? Children, of course, are the most susceptible because they crawl on the ground, they put everything in their mouths, they put their hands in their mouths. But you've got halogenated flame retardants. We cover everything with the flame retardant, right? Think about it. We cover pillows, mattresses, children's pajamas used to be covered with flame retardants. Remember when children's pajamas, as if that was going to save the day. Jimmy, you're okay. You got your pajamas on, buddy. Just run like hell, right? I'm like, what were we thinking, covering a little kid's pajamas with a flame retardant? Get your ass out of the house. My God. So the crazy thing, Paulo Laporte is an architect on the West Coast, right? 4 out of the top 5 chemicals we use in this country are not inventoried by the EPA. 4 out of the top 5, right? Does anybody here think they will be someday? They'll never be. Do you know how much money the chemical companies are making on the top 4 chemicals that they sell? Do you think that there's a lawmaker anywhere in Washington, D.C. that wants to take on the chemical companies? Oh, hey, by the way, I know you guys sell a lot of that chemical, like $1 billion worth, but we need you to stop making it because it's making people sick. It's not going to happen. So have you guys heard of the Red List? Heard the Red List? So the Red List is a list of known toxins that a group of scientists created based on their chemical footprint. So they didn't use names because some of the toxins have more than one name. They didn't want to double count. So they made a list of synthetic chemicals that are known to be toxic to plants, animals, and people. 815 chemicals long, right? 815. Isn't that ridiculous? Guess how many of them are illegal to manufacture with? 0. Are you guys picking up on the theme yet? 0 regulation. And so this wasn't something that human scale thought about a whole lot, right? Because human scale is what we call a complex manufacturer. And what that means is to make this chair, specifically this chair, this is called the Smart Chair, we work with 153 suppliers. How are we going to know what 153 suppliers are putting in the parts that they're selling us for this chair, right? It's a pretty big question. So what we had to do, oh my God, before I get into that, this is one of the problems, right? Awareness is a big issue today when you think about toxic chemicals and our proliferated use of toxic chemicals. I get this on my Instagram the other day. Not that I'm on Instagram that much. I'm really not on Instagram that much. But I get this on Instagram. This is a spray that you can put on your shoes, and nothing in the world will ever stick to your shoes. How toxic do you think that is? Let me tell you something. I'm not a material scientist. I don't profess to be one, but I know that the only chemical that can repel liquids is PFCs, okay? Perfluorinated compounds or perfluorinated chemicals, they're called both. PFCs, I'm going off on a bit of a tangent here, and I apologize, but it's a character flaw. PFCs are what they call persistent organic pollutants, okay? Organic is bad. It's bad because that means they're carbon-based, and we're carbon-based. So when we come into contact with something else that's carbon-based, our bodies absorb it very, very easily because we think it belongs there, all right? It's persistent because PFCs are the strongest molecularly bonded synthetic chemical that man has ever made. So the half-life on PFCs is like in the millions of years. And when you get it in your system, it'll last there for an average of 9 years. So these toxic chemicals that we talk about bioaccumulate. 90% of them are petroleum-based, believe it or not, right? So when you introduce them into the environment, they're going to stay there for pretty much forever. So when you talk to a manufacturer, I like this one too. So if you want to wear clothing that you can spill anything on, there's a company for you, right? You can pour Coca-Cola over your shoulder and still not have to wash the damn shirt, right? But imagine the PFCs that are woven into that fabric, that this company is saying, hey, put this clothing on and wear it all day long, right? And when you're 40, you'll develop a new allergy. It'll be shellfish or peanuts or something like that. Or cancer. I'm not going to, or cancer, possibly. Fear-mongering right now, cancer, yep.
Yeah, so, not to disturb your discussion, and I don't know if this is in line with it or not, the 5G situation.
In the ocean?
Yeah, just protecting yourself. How are you personally, like, protecting yourself from some of these chemicals through diet or?
How am I personally protecting myself from these chemicals? I don't think I am. I think I gave up.
The 5G thing that's coming, that's highly toxic as well to our bodies, especially people who are less melanated.
Mm.
So I'm studying that as well. So I'm just trying to figure out, we have all this going on, but to protect ourselves. So I'm a 70s baby, and you know, you're looking at all this cancer stuff popping up, just cancer just everywhere.
Yeah.
So it's linking, you know, to these chemicals.
The answer is in material transparency, right? And that's, we're getting there. We're getting closer to there. But right now, what we're finding is because we're so comfortable using all these toxins, because we're so comfortable spraying stuff on our shoes and buying clothing that repels absolutely everything, what do you guys think happens to this stuff? When we have mattresses and pillows that are covered with halogenated flame retardants, what do you think happens to this stuff, right? We are a take and make society. If we're not consuming, the economy is faltering, right? So we're making stuff, we're using it, it's going in a landfill, it's leaching, it's getting into the water, it's winding up in a stream or a river, it's going into the ocean. Orcas in the Pacific Northwest, I don't know if you guys knew this or not, but females live longer than males. Do you want to know why? Because females detoxify themselves when they give birth to their first calf. Orca whales have amongst the highest concentration of halogenated flame retardants of any mammal in North America because their bodies are so susceptible, they absorb it so easily. So the female detoxifies herself when she gives birth. Consequently, the firstborn calf doesn't live very long, but the female lives longer than the male for that reason. And the point of that story is that when you ask a manufacturer what's in their product, they're going to tell you a couple of things. They're going to say, first of all, if you're not eating the chair, don't worry about it, right? Like, you're not eating this stuff, it's not going to make you sick, which is not true because nobody's doing the research. Then they'll tell you, oh, we just use a little bit of PVC, or we just use very trace amounts of formaldehyde. We don't think it's enough to make you sick. Again, nobody's doing the research. But the problem is that once you introduce these toxins, they never go away, right? They wind up in landfills, they wind up in oceans, they wind up attaching themselves to microplastics, which then get consumed by smaller organisms that then get consumed by bigger organisms, and eventually the toxin winds up in apex predators like orca whales and people. That's how we get exposure. So back to what I was talking about with this chair. We work with 153 suppliers to make this chair, and we had to make it, we decided that we were going to make this chair free of all toxins, right? So we called 153 suppliers and asked them for their recipe, which is different than your ingredients, right? So think about it. If I had a chocolate chip cookie and it was really good, and I wanted to get the recipe for it, and the company said, well, we use flour, sugar, eggs, vanilla, chocolate chips. Those are just the ingredients, right? I need to get the recipe. What is in the chocolate chips, right? What is in the sugar, right? So it took a long time. Suppliers don't like it when you call them up and you ask them for their recipes. They usually don't call you back, right? It took us a little over 2 years before we got all of the recipes for this chair. And at the end of the 2-year period, we had to collect 214 recipes before we knew what was in that chair. Takes a long time, takes a lot of effort, takes a lot of money. And that's why a lot of manufacturers don't do it. And what some manufacturers will tell you is, hey, we get it. Like, material transparency is good. Like, you should know what's in your tables and what's in your chairs and what's in your wall coverings. You really should know that. We get that. But we're a complex manufacturer. We work with hundreds of suppliers. And these suppliers make a living on their proprietary recipes. And we want to respect the privacy of these suppliers. And so we're not going to share those recipes with you. But understand, we think it's a great thing. So that's really a bunch of baloney, because we had suppliers that wouldn't share with us either, and we had to fire them. We had a major chemical manufacturer that fired us. They didn't want to give us the recipe. They didn't want to take the toxin out of the part that they were making for us. So they fired us. I'm not going to say who it was, but it rhymes with DASF. Big companies, we're not a big company. We didn't have a lot of leverage. The good thing was that by the time we got fired and we fired suppliers, we were surrounded by a really good group of suppliers who wanted to help us figure it out. Since we identified all the toxins in this chair, we hired a material scientist. We've gone through every recipe of every product that we make, and everything we make is either red list free or toxin free. We have a couple of legacy products that have some bits and pieces that we still have to find alternatives for, but for the most part, we're pretty comfortable saying that. And of course, we found some really nasty stuff in our product. Any table, any work surface that you buy today that's got a composite to it uses formaldehyde as an adhesive because it's really super cheap. Formaldehyde is toxic. It's a carcinogen over a period of time. It manifests itself as itchiness and rashes and watery eyes when you first get exposed to it. But over time, it bioaccumulates. It's really nasty. How do we ever think to start using formaldehyde? It's an embalming fluid, right? And what manufacturers will tell you to complicate things is they'll tell you that formaldehyde off-gases from anything carbon-based off-gases from rotting wood will off-gas formaldehyde. But we're not talking about that. We're talking about the use of formaldehyde as an adhesive agent in composite wood surfaces. This is somebody dying from formaldehyde. I'm just kidding. I'm kidding. That was a joke. It was just a stock photo. He's a model, he's an actor. PVC, is all. We consume 14 billion tons of PVC. We disposed annually of about 7 billion tons of PVC. 2 to 4 billion tons wound up in landfills, okay, where it leaches and does all that nasty stuff and ends up back in apex predators. Flame retardants, you guys know the story of flame retardants real quick? So the state of California wrote a technical bulletin back in the 70s, TB 117, said if you want to sell furniture in the state of California, you got to cover it with a flame retardant. You guys hear about this? So guess what industry actually forced it onto the furniture industry? When the state of California originally was contemplating Technical Bulletin 117, do you know who they blamed for house fires? This is the 70s. I bet you guys can guess. They pointed their fingers at the cigarette industry, and they said, you guys are the leading cause of house fires in this country. You got to put some kind of a flame retardant in your tobacco so that if Uncle Arby falls asleep watching Hee-Haw at 2 o'clock in the morning, smoking a damn cigarette, he cannot go up in flames. And I can say that because I have an Uncle Arby. So the cigarette company did something really smart. You know what they did? They hired a lobbyist. And the lobbyist said, oh, everybody tap the brakes, slow down, we get it, house fires are bad. But The tobacco of a cigarette is a very, very delicate compound. And we don't want to make people sick now, do we? We can't put that in the tobacco. The problem is the furniture that the cigarette is falling on. That's what's catching fire. We don't even need this anymore today because we've got sprinkler systems and smoke alarms. What kills people in a fire today? Not to be morbid, but smoke inhalation. Not a Serenin table from the 3rd floor on fire, right? Smoke inhalation. Plus that, your kids all have flame retardant pajamas on, so what are you worried about? By the way, did you guys hear January 22nd, Cal 133 got overturned? True fact. January 22nd, Cal 133 made a lot of progress with flame retardants. PFCs, which I've already spoken about, but they are everywhere. I'll tell you a funny little story real quickly about PFCs, and I bet nobody here thought that they were going to hear a funny story about PFCs, did you? Funny story about PFCs. So we had to get PFCs out of our product. Every stain-resistant coating that we looked at contains PFCs, which are really, really bad, okay? We all know this now. PFCs, if you guys walk away with anything from this tonight, it's aside from water and air, my point will just be that PFCs are really, really bad. So we couldn't find a stain-resistant coating that did not contain PFCs. And we had to get rid of the PFCs. So we turned the problem over to our design engineers, and we said, you guys figure this out. And we gave them a bunch of our seat cushions that were covered with a stain-resistant coating. And the first thing they did was they said, hey, did anybody ever test the seat cushions after they got coated to make sure that the stain-resistant coating worked? Yeah, we were like, oh, shit. 20 years we've been using that stain-resistant coating and nobody ever thought to test it, just to make sure. So we tested it, and thank God. I know there were a few people that were like, my job is on the line, please pass. And it passed. And then they asked another brilliant question. They said, does anybody know how long the stain-resistant coating lasts? And we said, that's a pretty good question. So we gave them a bunch of seat cushions, and they hooked them up to Weizenbeek machines. You guys know what the Weizenbeek machines test for? So if those of you that don't know, the Weizenbeek machine will test for durability in commercial-grade textiles. It tests it with double rubs. So the industry standard is 30,000 double rubs. A double rub is like this, right? That's 1, that's 2, that's 3. You want to go all the way to 30,000? 4, 5, 6. So they tested it. Our textiles are really, really durable. They hold up to 150,000 double rubs. So who wants to guess how many double rubs the stain-resistant coating lasted for before it rubbed away, before it rubbed off? Yeah, there's another steel straw on the line here. Perfect, exactly. Between 1 and 10,000 double rubs, which when you drop that into a calendar, 6 or 7 months. So that's kind of a problem, right? Because we've got a warranty on our cushions, and now we have a stain-resistant coating that only lasts 7 months. What the hell? But here's the real problem. Where does it go? Where do the PFCs go? They rub off on your clothing and on your skin, and you take them home with you. You take the PFC home with you, right? And you wash it in the washing machine, and it goes into the water, right? And it ends up in an apex predator. Yeah. Mercury, which we all know is bad, chrome 6, hexavalent chromium, anything bright and shiny in your office or your house is very likely plated in chrome 6. Did you guys ever watch the Aaron Brockovich movie? That's about chrome 6 getting into the drinking water. Chrome 6 is highly toxic in the manufacturing process, but it also flakes off over time. So it's a really bad material to use, right? What you're looking at here is a photograph of a very small community outside of Houston, Manchester, Texas. They are what we call a fence line community, and if you don't know what a fence line community is, it's a community, generally speaking, very impoverished, that sits in an industrial area, and very likely it abuts 1, 2, 3, some never 4, but I guess 1, 2, 3 different industrial sites. So Manchester, behind them is the Valero oil refinery, okay? Manchester has a very high rate of cancer in their children, and they're trying to figure out what the heck is coming out of the smokestacks in that Valero oil refinery. But Valero doesn't have to tell them. So this is the first day of their hunger strike. They went on a hunger strike to force Valero to tell them what's in the smokestacks. It's coming out of that factory, right? So here's the problem. When I started out talking to you guys about material transparency, we were on this environmental discussion. But you see how it's evolved into a socioeconomic discussion? Because you don't have oil refineries in rich communities. You don't have chemical companies in countries that are educated and have money and can fight the chemical companies. It's a socioeconomic problem because when a manufacturer says to you, we don't use enough toxin to worry about, so don't worry about it. What you need to remind that manufacturer of is that that manufacturer is perpetuating a really bad thing because use of a toxic substance contaminates in a multitude of ways. You get exposure when you extract the raw material that's toxic. You get exposure when you work in a factory and have to handle that toxic material. You get exposure when you're in the fence line community. You get exposure in construction and installation. You get exposure through building occupants, people that have to use the product. And then you get exposure at the end of the life cycle when you bury it in a landfill, right? So it has nothing to do with how much you use. The fact of the matter is you're perpetuating this cycle. It's a really, really bad thing. This is a map of the toxic release inventory. Have you guys ever heard of the TRI, toxic release inventory? So there are 22,000 manufacturers that have to report to the TRI whenever they release a toxin into the atmosphere. So this map is from 2009, and in 2009, these 22,000 factories released 650 different known toxins into the air for a total of 4.8 million pounds of toxic release. Okay? Nothing wrong with that. It's not illegal. Right? So look at the map. So that's the map of the toxic release. That's the map of cancer incidents in the United States. Can you see a very slight correlation? Right here is what they call Cancer Alley. That's in Mississippi. That's where all the oil refineries are, right? So I wonder if I can go backwards. Yep, so that's the toxic release inventory. That's cancer rates in the U.S. Toxic release, cancer rates. Pretty morbid, right? Public information. So one of the things that you can do, all right, now let's talk about some good solutions here. Enough with the fear-mongering. One of the things that you can do is look for declare labels. Declare labels are like nutritional labels, but for furniture. They tell you where it's made, what it's made out of, and where it goes at the end of its life cycle. And it's very easy for a consumer to look at and read. If there's a toxin, they highlight it in red. If it's a chemical of concern, they highlight it in orange. The declare label is meant to reward transparency. So you can still have product that have toxic ingredients, but at least they're telling you that they have toxins. Yeah?
So I walk into Ashley's Furniture tomorrow. There's a list of this.
Only if the manufacturer's, it's voluntary reporting. Only if the manufacturer wants to report it. See? So that's why this is not going to come from federal regulation. It's probably not going to come from a lot of manufacturers that do the right thing. It's going to come from consumers that start asking the question, right? This is an example of how human scale incorporates the red list in our product design. So we learned the hard way, okay? We went backwards. We said, oh, what's in this chair? And we had to collect all these recipes. Today, this is an example of our bill of materials. We actually, I don't know if you probably can't see it, but we actually highlight that all materials are to be Living Product Challenge red list free, and metal parts are to be free of chrome 6. So we know when we're designing product what our materials are going to be, which saves us a lot of time and a lot of money. We're also, 2 minutes? 3 minutes? Oh.
Okay, so you have that in your product specification right there, right? Hey, you are going to supply something for our thing. It needs to be red list free. Now, isn't the burden of proof on you?
It is, yeah. Yeah, so we have to make sure that, well, and what's better for us is once we surround ourselves with appropriately behaving suppliers, it gets a lot more, the process gets a lot more transparent. We audit the factories, right? We run toxicology tests on the parts that we get, so it gets a lot easier once you've done it once. And we're trying to minimize our use of plastic. I just want to talk about plastic for a minute because this is really my pet peeve. Do you guys think we do a good job recycling in this country? Globally? No, I wouldn't. Listen, you know enough about me now to know I wouldn't want to talk about it if it was good. We recycle at a rate of about 9% of what we consume. 9%. You guys want to know why? I'll tell you why real quick. There's two big reasons. The number one reason is we're consuming way too much plastic. Blame Unilever, blame Procter & Gamble, all those single-use wrappers that we use all the time, right? We're consuming so much plastic, and if you don't know this, plastic is not recyclable, people. It's based on the linear economy. You're supposed to use it and then throw it away, out of sight, out of mind. What don't you get? You can't recycle it. Manufacturers, most of this plastic that we use, manufacturers can't make anything out of it. And I used to think, what's the big deal? Take it all, pour it in a pot, melt it, stir it up, and pour it into molds, right? It'll just break apart. Plastics, of different kinds of plastics, just don't bond to each other, right? That's the first reason why we don't recycle very much. The second reason why we don't recycle very much is called aspirational recycling. Have you ever heard that term, aspirational recycling? I love that term. It might be my favorite term. I use it all the time. I say, quit aspirationally recycling. Aspirational recycling is this. I'm literally in a Starbucks in Montreal, and I'm walking out with a colleague of mine, and I go, hey, what do you think we'll find if we pop the lid off this recycle container? He's like, don't do that. I said, you guys are Canadians, you won't mind. I popped the lid off. So here's a recycling container that has 3 different holes so you can separate it. Somebody at Starbucks got really tired of taking 3 garbage bags out of every container. And so now it's just 1 garbage bag. And you can't even recycle Starbucks cups, guys, because they're lined. You can't recycle them. And you can't have food in recycling. It just spoils the whole batch. So this is all going to go in a landfill. But everybody that leaves a Starbucks can feel so good about the fact that they took a minute and separated their recycling, right? So this is another one. I took this picture. I'm in a hotel in New Jersey, right? And this is my garbage can. I pop the lid off, and my wife is like, listen, you and these lids, it's turning into a problem. I said, let's just see how this works. I want to see how it works. So I took the lid off, popped the lid. It's 1 garbage bag. Can you see how it goes over the separator? So housekeeping will come in, they'll take 1 garbage bag out. Whatever I do here, it's all going to go in the landfill. And that's what happens, right? It goes in the landfill, and then the landfill floods, and all that light plastic floats up with the water, drains out of the landfill. I'm on a run. I'm going on a run. This actually was exactly what it looked like. I was running down the Mississippi River in St. Louis, and I saw all this plastic against the pier, and I thought, that is so gross. It was all water bottles and stuff. I stopped and I took a picture as a garbage barge was going by. I was like, how ironic. Couldn't have planned it any better if I wanted to. Once it gets into the river, like the Mississippi River, guess where it ends up? In the ocean. Where? Galveston? I don't know Texas well enough to agree with that statement. But this is a scuba diver. He's diving through what's called, have you guys ever heard of the Great Pacific Garbage Patch? You guys are like notorious because they always compare it to the size of Texas. They say it's the size of Texas. And I think it makes Texas look a little guilty when they do that. It's like guilt by association. It's a patch of garbage the size of Texas. Freaking Texas. About 475,000 tons of garbage. And a lot of people think it's just a floating island of garbage. And we should go out there with boats and skim it all off the ocean and get it. But you can't, because as you can see in this video, it's more like a plastic stew, right? The problem is that most of the plastic in the ocean is under 20 years old, because it breaks down that quickly. The problem is it breaks down into microplastics that we can't get to, and fish eat them. And a lot of the plastic actually winds up at the bottom of the ocean in the form of fecal pellets. It's fish poop. But fish and animals still eat it. We let about 8 million tons of plastic into the ocean every year. And if you want to know what that looks like, 8 million tons, that's a garbage truck dumped into the ocean every minute, every hour, every day for a year. So it's a garbage truck a minute. That's 8 million tons. Scientists estimate that by 2025, by weight, the plastic will weigh a third the marine life, and that by 2050, they'll weigh the same. That's how fast we're filling the ocean with plastic, right? And once it gets in that ocean, you're not going to get it. You're not going to get it because most of it sinks down to the bottom, and we can't get it. Yeah, we do beach cleanups. They're good. You see the videos of like scuba divers that go down and try to rescue as much as they can. It's just a drop in the bucket, right? So our CEO is an avid fisherman, and he's really, really passionate about ocean plastic because 20% of it is actually discarded fishing gear. You guys ever heard of ghost fishing? Ghost fishing is a term for discarded fishing gear. Sometimes it happens because of a storm, right? 80% of the believe it or not, I don't think it's 80%. A high percentage of the plastic in the Great Pacific Garbage Patch is fishing gear from the Japanese tsunami a few years ago. See, that Great Pacific Garbage Patch is like a confluence of currents and trade winds. That's what collects all the plastic there. But 20% of the plastic in the ocean is discarded fishing gear. And what happens is a fisherman gets their net hung up on a reef or rocks, and they ruin it, they tear it. And then rather than like continuing to pull this net up that's ruined, they just cut it loose and they let it drift away. And the problem is that these nets, a lot of them are made out of nylon 6, which can last in the ocean for 1,000 years. And they catch fish until the weight of the carcass forces the net down to the bottom of the ocean. Bottom feeders and crustaceans come out, they eat what's in the net, it floats back up again, and it does it all over again. Scientists estimate that we lose about 10,000 animals annually to ghost fishing. So it's a real problem, and it's been something that we've been talking about for a really long time. And we met this company at a product expo in Pittsburgh about 3 years ago, and it's a company called Borreo. They're based in Ventura, California. 4 guys started it, chemical engineers, they're surfers. They got tired of surfing through plastic and learned that these fishing nets are made out of nylon 6, which is actually a pretty good material for manufacturing. So they put together a program using a grant from the government of Chile to buy back damaged fishing nets from the Chilean fishermen. Chile had a perfect recycling center that actually recycled nylon 6. So they buy the nets back from the fishermen, they clean them, they chop them up, and they recycle them into nylon pellets. And they were making skateboards and sunglasses out of it, because if you're a company in California, what else do you do? Skateboards and sunglasses, right? We saw these nylon pellets, and we were like, hey, wait a minute. Give us those nylon pellets. Let us see this, because we use nylon in our product, right? Now, I'll tell you something right now. We never would have done this had we not decided to go toxin-free with our product, because that's where our design engineers learned something valuable. It used to be their job was to drive the cost out of this chair. If this arm costs $3, get it for $1.50. Call the supplier right now, get it for $1.50. So we were working with suppliers that did whatever they could to get stuff as cheap as they could. Not really the best suppliers in the world to be working with. But our designers learned how to work with the ingredients of the chair, right? And they learned how to develop relationships with suppliers that were transparent. And so they realized that we could make a material substitution, because the back of this chair is a glass-filled nylon. So we work with Borreo now. We buy those nylon pellets from them. We make the Smart Ocean chair using the Borreo nylon. So each of these Smart Ocean chairs uses about 2 pounds of discarded fishing net, which is cool, right? It's not going to fix the problem overnight, but our goal is to show other manufacturers that you've got to be a little bit more creative in how you source out your materials. It can't just be the cheapest thing you can possibly get. And let's face it, most companies in this industry, they do what's really easy, what's really convenient. They love to talk about recycled product, recycled content, because everybody's using recycled content. Most of the time, recycled content is cheaper than virgin content. So they're not doing anybody any favors, right? So this is actually just an interesting story of sourcing out a new material. And I wanted to end on a positive note because I knew that I was depressing you guys. So hopefully everybody feels good about themselves. Don't worry about going home and putting on hazmat suits, although I would recommend it. I actually had a boss that used to wear a hazmat suit when she traveled. She would like go to a hotel room and put a hazmat suit on. I only know that because she told me. So, anybody have any questions or anything? Yeah. This is your last one, by the way. No, just kidding.
So again, okay, so human scale, you guys have regular like household furniture?
Not for household. Yeah, we're a commercial furniture we're not really a furniture manufacturer. We're a commercial manufacturer, but we manufacture tools and elements to go into workstations like monitor arms, task lights, task chairs, sit-stand work surfaces, things like that. Yeah.
You have an office in Texas?
We have an office and a showroom right here. In fact, our big cheese is back there in the back row. She's the one in charge. So if you want any special deals, Lily Pritchett, wave your hand. Lily's cutting special deals tonight only. Special deals. Thank you, everybody. I appreciate it. Thanks.
Put you on the spot. So, what do you do when somebody sends you back a suit for a chair?
So, end-of-life solutions are particularly challenging, right? It's a rabbit hole, right? You don't want to send stuff all the way across the country to be disassembled. So we do a couple things. We make our product extremely easy to disassemble. We don't have any proprietary connectors or screws or anything like that. Anybody can go online and they can download disassembly instructions and they can take our product apart very, very easily. If they call the 1-800 number, there'll be a trained professional on the other end of the line that will help them source out a local partner that we're familiar with who will help them recycle that product or repurpose it. We also work with a group called Anew. Has anybody heard of Anew? Good, okay, good. Yeah, Anew is a great organization that's trying to defer product away from landfills, right? So what they'll do is if you've got product that you don't want anymore, you don't want to, you're getting to the point where you're just going to have somebody haul it away, call Anew and they'll put you in touch with a charity and you can make a charitable donation. Yeah.
What does Human Scale do for Earth Day every year?
What does Human Scale do for Earth Day every year? There, I repeated the question. Was that good? I get an A+ for the night. We celebrate it in our factory in Piscataway, New Jersey, and we invite the community to come into the factory, and all of our employees bring their families, and we have like crafts for kids. We give tours because we have a solar system on the roof of our factory that generates about 90% of our energy needs for the factory. We have a rainwater catchment system. We have trails for walking that we put around. So we spend a day in the factory and kind of celebrate Earth Day. Yeah. Did you have a question?
You said they were recycled, right?
They can be.
But they're made out of recycled material.
Yes, yeah, they do. I don't know what the content is. I don't know what the...
It's just a plastic is not recyclable.
I was generalizing. Not all plastic is not recyclable. Water bottles, for example, are very easily recyclable. They're probably the most popular item that you hear about getting recycled, right? Generally speaking, plastic is very difficult to recycle. Thank you.
And then finally,
Oh, separate.
we have one of these, a few of these, and so I want John to notice. Now, if we do a good job, that's a whole other story, but at least we don't have the single bag,
I'm disappointed, and I will not be taking a picture of that.
Yeah.
Take a picture to show others.
Right.
That's right. I'll say USGBC in Texas.
How about a round of applause for
All right, well, that's our story, and we're sticking to it, and come back next month, and thanks so much for being here.